All right. So let's talk a little bit about actual chemical reactions, right? Because the whole point of this unit is stoichiometry in solutions. So the next thing we need to know is how to write chemical equations, because we need balanced chemical equations for stoichiometry. Side note: Pika's right here. Look at her. Look at her. I'll go wake her up. What a cutie. All right. Anyways, let's check her out. Not check her out. Let's check this out. All right. So, what you're gonna need. Hopefully, you've gone on enough practice of solubility rules, and you can do it like that now. Sorry if I snapped. I don't think that was a good snap. Anyways. Well, since a lot of the chemical equation is kind of like not really useful or it's not essential, we have to learn to able to trim it down to only the important parts of what actually react. All right, so let's take a look at some of these problems. We're going to need 3 skills. Writing a formula equation, so taking out words, writing in a chemical formula. You should already know how to do that. The next thing is breaking apart that formula into its ions. And then finally, removing the unnecessary ions so we can see what the actual reaction was. All right, and that's going to be called the net ionic equation. So let's take a look at first writing formula equations. So it's a reaction between copper chloride, so CuCl2, and we got to determine, is that a solid or is that aqueous? And it's reacting with potassium iodide, Ki. Now I know that anything in group 1, automatically all alkali metals are soluble in water. So this Ki is going to be AQ. Pretend that says AQ. Pretend you can see that. Now the next thing is chloride. It's a chloride. So let's check right here. So hydroxides, carbonates, phosphates, sulfates, chlorides. All chlorides are soluble in water, except those 4. Okay, it doesn't have any of those 4, so it is aqueous. All right, now let's do a double replacement right here real quick. Now that's going to be KCl. K is +1, Cl is -1. So that's good. And then over here, we'll Cu. Oh, Mr. Sanchez, what the hell is that? Why is there 2 arrows? So it's Cu I2. Now I like balancing things because I don't know, because it's the right thing to do. Okay, why do we do some things? Because it's the right thing to do. Okay, all right, this one, iodines or iodides are soluble, so this is aqueous as well. So if everything is aqueous, it kind of looks like it's not going to react, because they're floating in water in the beginning and they're floating in water at the end. But let's check this out. This should actually be a no reaction. It's no reaction. This doesn't happen. Nothing. You mix them and they stay floating. So, but yeah, so let's go on to the next problem. Whoopsie daisy. All right, the complete ionic equation, I can show you what's actually happening. So Cu, let's balance it first though. There's 2 KCl's and then 2 right here. So Cu, well, that's Cu +2. And then there's 2 Cl minuses floating around. And then there are 2 K pluses floating around. And then there's 2 I's floating around. Mr. Sanchez, isn't chlorine and iodine a diatomic? Yes, but this isn't an ion form. In ion form, they're not diatomics. Right hand side, well, there's 2 K's right here. Oh, well, there's also 2 Cl's over here. Sorry for my writing is ugly. I want to save time for the actual examples. There's 1 Cu +2 right here, and then there's 2 I minuses. Now, all of these have their own states of matter. They're all aqueous. They're all dissolved in water. But if you take a look at it, look, the Cu and the Cu appear on both sides. The two chlorines appear on both sides. The two Ks appear on both sides. The two Is appear on both sides. So nothing reacts. Nothing reacts because it's the same on the left as it is on the right. So, ow, I hit myself. Hey. All right, so this doesn't react. Let's check one out where it actually does react. So let's take a look. Let's move me. And let's look at some of your work. Hello. Let's take a look at number 64. Let's make that a little bit bigger. And let's do the same thing we did before. All right. So, side note, some of these problems don't work. I use ChatGPT because I'm lazy to write some of these problems, okay? Extra credit to whoever finds mistakes. All right, so zinc nitrate. That's so bad. I shouldn't be doing that. Mr. Sanchez, you should be doing all your work. Shut up. You should too. All right, but you get graded on it. All right, so zinc nitrate plus Na2S. And anything in group 1, any of the alkaline metals, well, what do I do? Hello? Uh-oh. See what you guys have done for making fun of me? We'll just scoot this up. All right, so all alkaline metals must be aqueous. So that Na2S, as soon as you see Na, you're like, oh, automatically that one's aqueous. And as soon as you see NO3, automatically you should be thinking, oh, that one's aqueous. So over here is NaNO3. Oh, what's that one going to be? I just said it. And if you weren't listening, it's aqueous. Mr. Sanchez, how do we know it's aqueous? Rewind the video. No, NO3, always aqueous. Na, always aqueous. Mr. Sanchez, why you repeat yourself all the time? So I can remember myself. Zn is +2 and S is -2. All right, so let's check it out right here. They said this one was aqueous. Said this one was aqueous. This one was aqueous. Mr. Sanchez, this is no reaction. I'm quitting. All right. Right here it says all sulfates are soluble in water except these. Ah, Mr. Sanchez, you done goofed. Psych. This is a sulfide, not a sulfate. Not a sulfate. Be careful. Anything that ends with ATE or ITE has oxygen. Okay, this doesn't end with ATE or ITE. It doesn't have oxygen. So, finally, about damn time, it's a solid. All right, so that is the formula equation. You should be pros at that by now. But let's write out the complete ionic equation. Let's break this apart into its ions. So zinc, oh, let's balance first, Mr. Sanchez. Don't be a dummy. Don't be a dummy. There's 2 NO3s here, so let's put a 2 right here. All right, there's 2 NAs. Oh, that seems to be it. Yes, I love when balancing is that easy. Yes. All right, so zinc is +2. And that's aqueous, but we're not going to write that down because they're going to. And then NO3, we should write that down. But there's 2 NO3s, and it's -1. And then over here, there's 2 NAs, and they have a positive charge. And then there's 1 S, and it has a -2 charge. And on the right-hand side, we got 2 NAs, and they're plus. And then there's 2 NO3s, and they're minus. And then there's a zinc sulfide that does not break apart. All salt, since it's a solid, it doesn't break apart. It doesn't dissociate. You can't break it apart into its ions. Only things that are dissolved in water can break apart into its ions. So only the aqueous stuff will do that. Mr. Sanchez, will liquids do that? Only the aqueous things. Mr. Sanchez, will gases do that? Only the aqueous things. Mr. Sanchez, will the aqueous things do that? Yes, they will. Okay, so let's check this out. So the zinc on the left doesn't cancel because it looks different on the left than it does on the right. Something changed. NO3s, it's the same. The NAs, it's the same. The S is different. So that right there is going to help us narrow down our net ionic equation. Our net ionic equation is Zn plus 2 plus S minus 2 will produce zinc sulfide solid. And we're going to put our states of matter here at the bottom because that's when the states of matter matter. All right, so right here, that's a Z. This is our net ionic equation. This is what's actually happening. These are the things that are actually reacting, the things that change. One of the most important changes that are occurring here is the charges. Zinc went from zinc plus 2 to whatever it is in there. This one went from a negative 2 to whatever it is in there. The state of matter, not the state of matter, the oxidation state changed. We're going to talk about that soon, okay? But basically, this is what you're going to do for all these problems. And then we're going to start doing some actual stoichiometry, okay? Some actual problems involving these things. Peace out, people. I think my hair is a little messed up. Oh, well.